and welcome to another Common Core Geometry lesson by eMathInstruction. My name is Kirk Weiler, and today we're going to be doing Unit 8, Lesson number 4, on solving for missing sides of a triangle. And I'm not talking about sides that just aren't there, but the lengths of sides, right? So this is really kind of cool because using right triangle trigonometry, and I really should have maybe called it solving for missing sides of a right triangle, but by using right triangle trigonometry and the fact that all right triangles that have a given acute angle are similar to one another, we can actually find the lengths of missing sides of a right triangle if we know at least one side and one of the acute angles. And of course, if we have our calculators. So make sure you have those things handy, and let's jump right into it. All right, first, a review of how to solve missing angles. We did this in the last lesson when we learned how to use our calculator to help us out with trigonometry. So let's take a look. Exercise number 1. Given the right triangle shown below, set up a trigonometric ratio involving angle A and then use it to find the measure of angle A to the nearest degree. Be good about your use of mathematical notation. All right, so here we go. Angle A, right? Remember how to solve for missing angles. Actually, maybe you do, maybe you don't. Let me ask you to pause the video right now and try to figure out what the measure of angle A is using your calculator and using trigonometry. Take a few minutes. All right, let's go through it. Remember, the most important thing is to identify the correct trig ratio that we're working with. And given the fact that we have angle A and we have the hypotenuse, right, then the question is, what's the 17? And the 17 is the adjacent side. So the trig ratio that relates the angle, the adjacent side, and the hypotenuse happens to be cosine, right? SOHCAHTOA, cosine. So we can write down the following equation. The cosine of angle A must be 17 divided by 22. Now that doesn't tell us what the angle is. It only tells us what the ratio is. We need our calculators to tell us the angle, and specifically we need to use what's known as the inverse cosine. So the angle A will actually be the inverse cosine of the ratio 17 divided by 22. And again, for this, I'll have to pop out of this program really quick and go into my calculator. Now, before I do anything on this, I have to make sure my calculator is in the right mode, in degree mode, all right? So I'm going to hit my mode button. Okay, and what I see right now is actually my calculator is in radian mode. So I'm going to bring the cursor down really quick, go over, hit enter. Degree is now highlighted, radian is not highlighted, and I'm going to get out of here. Now remember, what I had was that the cosine of angle A was 17/22, so angle A will be the inverse cosine, that little -1 tells us it's an inverse, of 17/22. So, easy enough, I'm going to ask my calculator to do the inverse cosine. Remember, you get that by hitting the second button and the cosine button. Now I'll put in 17 divided by 22. I'll hit enter, and my angle is 39.4005, etc. All right, it's about a 40-degree angle. If your calculator was in radians, you'd get an answer here that's in the radian unit of angle measurement, which you still haven't been exposed to. I was going to say you're not comfortable with because you've never even seen it. Anyway, so 39.4 degrees, I think we wanted it rounded to the nearest degree, you bet. So this is going to be 39 degrees. It was 39.4, but that would round to 39. All right, that's how we solve for an angle, and it's so simple, right? Set up the ratio, right? Identify the right ratio, set it up, and then use the inverse trig function in order to come up with the angle. But now let's move on and do a little bit of algebra before we solve for missing sides. Okay? The algebra that we need to solve for missing sides of right triangles is simple rational algebra. I mean, it's real easy. So let's take a look at exercise number 2. In each of the following, quickly solve for the value of x. Show each of your steps. All right? So in other words, I need to be able to solve this equation for x. But this should be a piece of cake because what's going on here is I've got x divided by 6 equals 5. I'm not going to cross multiply. I'm just going to multiply both sides by 6, and I'm going to get x is equal to 30, right? That's a piece of cake. Now, in the case of letter B, this is a bit trickier because the x that I'm solving for is in the denominator. But still, although it might take me one additional line, what I'm going to do here is I'm going to multiply both sides by x. That's going to give me 3x is equal to 18. Divide both sides by 3, and x will be equal to 6. Right? Piece of cake. It gets a little bit trickier when there's other letters involved, right, and no numbers. And yet, the procedure is still exactly the same. In this case, I've got b equals x divided by a. I want to solve for x, so I'm just going to rewrite the equation really quickly. And again, very simple. All I'm going to do to get my a by itself is my x by itself is multiply both sides by a, and I just get x equals a times b. You don't need the little dot there. You could just have ab. That would be fine. All right. And finally, again, another one where the variable I'm trying to solve for is in the denominator. All that means is I've got an extra step, but it's still pretty easy. If I've got a divided by x is equal to b, and I multiply both sides by x to get it out of the denominator, I'll now have a equals b times x. Now I want to get the x all by itself, so I divide both sides by b, and I get x equals a divided by b. All right, if you can do this algebra, and you can set up the proper trig ratio, there's nothing that you can't do without right triangle trig in terms of the problems that are going to be thrown at you. It's actually one of the easier parts of this course. You should thoroughly enjoy this lesson and the next two. They're kind of fun and they're not overly hard. All right, so let's kind of jump right into it and see what we're doing. SOHCAHTOA. Let's take a look at exercise 3 and solve for a couple missing sides. In the following diagram, one of the acute angles is given and one of the legs. Solve for each of the other sides of the right triangle. Round your answers to the nearest tenth. All right, so here we go. And this is a classic scenario. I've got a right triangle and I know one of the acute angles. Now keep in mind, I could also subtract that angle from 90 and get the other acute angle. But the plain fact is, I know that acute angle and I know one side, and that's critical. I have to know at least one side of the three sides, or there's no way I can find any of the other ones. Okay, I gotta have that 28. But let's take a look at what we're asked for in letter A. It says solve for the length of side MP. That's this length here. All right, I think I'm gonna give it a variable name. I'll call it x. Okay, and now what I wanna do is something I've been doing for the last couple lessons. I wanna look at the acute angle, the 36 degrees, the 28, and the x. I don't even want to worry about that side. I'm not going to even think about side NP. Not even going to go there. And I want to figure out the right trig ratio that will relate this angle to this side and this side. Think about that for a moment. Which trig ratio will relate that acute angle to that side and that side? Well, it's going to be the tangent ratio, right? Because the x is the side opposite and the 28 is the side adjacent. So I can literally say that the tangent of 36 degrees is equal to x divided by 28. Now remember, I'm trying to solve for x. I'm trying to solve for it. Now the tangent of 36 is some messy decimal. Right? We could take our calculator out right now and be like, tell me what the tangent of 36 degrees is. I'm going to leave it though for right now. I'm not going to touch it. In fact, what I'd like to do is I'd like to solve for x by multiplying both sides of this equation by 28. And what I find is that x will be equal to 28 times the tangent of 36 degrees. And the beautiful thing now is that I can just type this expression, 28 times the tangent of 36 degrees, right into my calculator. Watch. All right, we want 28 times the tangent of 36. We don't really even need that time symbol. We could just do 28 tan 36. And we get 20.343, etc. That's the value of x. That's the length of that side. Now we wanted our answer rounded to the nearest tenth, so my final answer is going to be 20.3. Let's go over and do that. 20.3, that's that side length. Second part of the problem asks me to solve for the length of side Pn. All right. Now I don't want to call that x because I've already used x. It's bad form to use the same variable in a given problem for the two different quantities. Once you've used x, you've used x. Now we'll use y, or you could use h for hypotenuse, whatever. Now again, what I'm going to do is I'm going to get rid of all of this. In fact, I'm going to get rid of all of that, okay? And now again, let's talk about which ratio we should be using. It's all about the angle. The ratio is all about the angle, that 36 degrees. The 28 is still the adjacent side, but now the y is the hypotenuse, okay? And if we've got adjacent and hypotenuse, we're using cosine. So specifically what I'm going to be writing down here is I'm going to say, the cosine of 36 degrees is equal to the adjacent side divided by the hypotenuse. You remember those problems back in the last exercise where the variable we were trying to solve for was in the denominator? Well, here's a situation like that. Now be careful. Be careful. Just be faithful to what you're doing. All right, I'm going to multiply both sides by y. That's going to cancel, right? So now I have y times the cosine of 36 equals 28. And keep in mind again, cosine of 36 is just some messy decimal. If you really needed to, you could evaluate that decimal right now and have that decimal times y equals the 28, all right? But there's no absolute need to. In fact, you can go from here and then just divide by this. Divide by cosine of 36 degrees. Right? And now I want to put this expression into my calculator. Easy enough. 28 divided by the cosine of 36 degrees. All right, here we go. 28 divided by cosine of 36. And that now is the length of my hypotenuse, rounded to the nearest tenth, 34.6. 34.6. Okay, now we've got our two missing sides. That's as easy as it gets. Sorry, that's as hard as it gets, I mean. These problems won't get any harder. The next two lessons we're actually going to spend on trigonometric applications because there's many of them. But anytime you solve for a missing side, it's either going to be this or it's going to be that. This is a little bit more challenging because we have to multiply first and then divide, whereas in this one all we have to do is multiply. But still, it's not like letter B was all that difficult. So let me step out of the way for a moment, take a second, and write down anything you need to. Okay, let's do some more. Here we go. Keys to solving for a missing side of a right triangle. Okay, number one, know one side and one acute angle. You need an acute angle and you need a side length. Once you have them, set up the proper trig proportion using the angle and the sides, right? Is it sine, is it cosine, or is it tangent? And again, that's all about looking at the angle you know, the side that you know, and the side you want, and coming up with the right trig ratio. And finally, number three, solve the proportion for the missing side, right? That's it. I mean, and it will be an easy proportion every time. So let's take a look at exercise 4. It says use the diagram below and trigonometry to find the length of BC to the nearest tenth. So what I'd like you to do is pause the video now and see if you can do this on your own. All right, let's go through it. Well, again, we're looking for BC. I think I'll call it X just to make it a little bit simpler on myself. Now what I want to do is I want to key in on the angle. I want to look at the X and I want to look at the 18. The 18 is the hypotenuse and the X is the adjacent side. So it looks like I'm back to cosine, right? Cosine is adjacent over hypotenuse. So I can say that the cosine, whoops, I don't know where my O went there. The cosine of 24 degrees is equal to the side adjacent, which is what I'm looking for, divided by the hypotenuse. This is one of those easy ones. I can now multiply both sides simply by 18. And I'll get the side that I'm looking for to be 18 times the cosine of 24 degrees, and that's now where I need my calculator. All right, so 18 times the cosine of 24 degrees equals 16.44, etc. Typically, you're asked to round these to the nearest tenth. Is that the case? Yep. So 16.4. Always keep in mind when you're doing trig problems. So this is a good, helpful check to see whether or not your answer is reasonable. The hypotenuse will always be the longest side. So in this case, if we had gotten an answer that was bigger than the 18, we would know that we were wrong. 16.4 is smaller than 18, so it seems at least that we could have the right answer. Put a slightly bigger decimal point there. Hard to see those decimal points. All right. Step out of the way, copy down anything you need to. Of course, if you got the 16.4, you're on a good path to understanding how to do this. All right, let's keep going. Another problem. These are going to start to seem probably pretty redundant to you because they're all very, very similar to one another. Exercise number 5. An isosceles triangle has a base of 26 inches and base angles that measure 64 degrees. Determine A, the height of the isosceles triangle to the nearest tenth, and B, the length of its legs to the nearest tenth. All right, so we've got to draw a good picture here. We've got an isosceles triangle. Its base is 26 inches. We don't know the lengths of its legs, but we do know that it has base angles that measure 64 degrees. So let's get a good picture of it over here. All right, we know that. Okay, these two sides are the same length. We know this is 26 inches, and we know these two are both 64 inches, right? The base angles of an isosceles triangle are equal. Now, one thing to keep in mind is that right triangle trigonometry, by its very definition, only works with right triangles, and this is not a right triangle. But you can always split an isosceles triangle into two congruent right triangles by simply drawing the altitude, which is also the median, and the angle bisector of the vertex. So I can always do that, and now I'm dealing with this right triangle. All right, 64 degrees, and this is key, this is now 13, right? And what I'm looking for in letter A is the height of this right triangle, so I actually want this. So now I can use trig, right? I'm dealing with a right triangle. I have an acute angle, 64 degrees. I have one of the legs, 13, and I'm looking for the other leg, right? That height. So which trig ratio do I need to use? Think about this for a moment, and then we'll go through it together. You have to use tangent, right? The h is the side opposite of that angle. The 13 is the side adjacent. So I would say that the tangent of 64 degrees is equal to the side opposite, h, the side divided by the side adjacent, 13. It is really important, obviously, that you don't have 26 there, that you have 13. Okay, remember, only deal with right triangles. But now solving for h is going to be as simple as just multiplying both sides by 13. H is now 13 times the tangent of 64. 13 tan 64. Notice I don't even need the time symbol, and I get 26.65, etc. 26.7 to the nearest tenth. And there's the height of my isosceles triangle. All right, now, letter B asks us to find the length of one of its legs to the nearest tenth. Now, just by definition, in an isosceles triangle, the two legs have the same length, okay? It's the base that could have a different length, unless it's an equilateral triangle, and then they're all the same length, but that gets a little boring. Now, we can go right back to this right triangle. I'm going to draw it a little bit bigger, hopefully a little bit neater, not necessarily. So that's now 64 degrees. Right? We know this is 13. We could, I suppose, put the 26.7 on there, but you should never use a previously calculated answer to find a further one unless you're instructed to do so or you absolutely need to do so. And then you should use the unrounded version, not the 26.7, but the 26 point da 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 da, right? Anyway, now what I want to do is I want to find the length of one of its legs. I've already used the letter h, I'm not going to use that again, but I'd use x. Which trig ratio should we be using here based on the 64, the 13, and the x? Think about this for a moment and try to write down a correct equation. Well, hopefully you said cosine. And after a little while, these should start to get easier for you. The 13 is adjacent. The x is obviously the hypotenuse. So we can now say that the cosine of 64 degrees is equal to the side adjacent, 13, divided by the hypotenuse, which is actually what we're trying to find. Now again, this is going to be one of those ones that's slightly longer than before because what we're trying to solve for is in the denominator as opposed to being in the numerator. But I can just multiply both sides by x, right? That'll give me x times the cosine of 64 degrees is equal to 13. And now to get x all by itself, I can divide both sides by the cosine of 64 degrees. And x should be 13 divided by the cosine of 64. 13 divided by cosine of 64 equals 29.655. So let's say 29.7. All right. 29.7. Okay? 26.7, 29.7. Okay, again, that's it. Have your right triangle, an acute angle is known, a side is known. Figure out the right trig ratio by looking at that angle, the side you know, the side you want. Set up an equation, a proportional equation, cross multiply or solve that equation the way that we've been going through, and you have your side lengths. It's that simple. Let me kind of step out of the way for a second, copy down anything you need to. All right, let's keep going. One more problem. Here we go. Multiple choice problem to kind of check your understanding at the end. Let's read through it together. Exercise number 6. In right triangle PQR, angle Q is a right angle. Measure of angle R is 48 degrees, and PQ is 11. Which of the following expressions correctly calculates the length of PR? All right, what I'd like you to do is pause the video right now and see if you can figure out the correct answer. All right, let's go through it. Good picture is helpful. Maybe not completely necessary, but I think it's pretty important. We've got our right triangle, PQR. Looks like angle Q is the right angle. Angle R is 48 degrees. I might as well put it down here. And I'll put P there. It says PQ is 11. All right, which of the following expressions correctly calculates the length of PR? Well, this is PR, so I'll call that X. All right, and now I have to look at the side that I know, the side that I want, and the angle, and relate them all together. So for that 48 degrees, the 11 is opposite. The x is the hypotenuse. So I can say opposite hypotenuse, that must be the sine. The sine of 48 degrees is the side opposite, the 11 divided by the hypotenuse, x. Again, slightly more challenging because what I'm solving for is in the denominator, but I could multiply both sides by x, cancel that out, divide both sides by the sine of 48, and I find that x is equal to 11 divided by the sine of 48 degrees. For choice 1. All right, and again, pretty easy, pretty standard, right? It just takes drawing a good picture, labeling everything that I know, that I want, the angle that I have, setting up the correct trig ratio, and then solving it for the variable I want. We don't even need to use our calculator on this one. All right, let's wrap up this lesson. So today what we concentrated on was how to take a right triangle where you know one of the acute angles and, very important, you know one of the sides. Once you have that, an acute angle and one of the sides, you can solve for any other side using the correct trig ratio and a little bit of pretty simple algebra. We're going to see how to do that much more in the next 2 lessons as we start to apply right triangle trigonometry to solve all sorts of different real-world scenarios. For now, I'd like to thank you for joining me for another Common Core Geometry lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.